and welcome. And in this video, we're going to be taking a look at a special type of factoring, which is called difference of squares, okay? Now, difference of squares is a special method that's reserved for only very special cases. But before we get to that, once again, I want to introduce it with a multiplication problem. So let's say we have something like this, x plus 3 times x minus 3. Well, we would normally multiply this out, right? You probably remember it as FOIL. It's the same as distributing twice. So I would distribute the x to the x to get x squared. I distribute the x to the negative 3 to get negative 3x. I distribute the 3 to the x to get 3x, and I would distribute the 3 to the negative 3 to get negative 9. And then I would just go ahead and combine like terms, which would leave me with x squared minus 9, because the 3 x's would end up canceling, leaving me with just x squared minus 9. And this is where difference of squares actually comes into play. What you should recognize is that x squared is a perfect square, and 9 is also a perfect square. So what we are doing is we are literally subtracting two perfect squares. And remember, another way of talking about subtraction is talking about the difference. So this is where difference of squares comes from. It is from subtracting two perfect squares. So this is a special method, and it's actually pretty easy as long as you can recognize if it's a perfect square or not. So the formula for difference of squares is if we are subtracting two perfect squares and we want to factor it, what it would become is x minus a and x plus a. So basically we take the square root of each individual term. So if I wanted to go back from x squared minus 9 and factor backwards, basically undo the multiplication I just did, I would take the square root of x squared, which is x, and I take the square root of 9, which is 3. And one of the binomials is going to be addition, and the other binomial is going to end up being subtraction. So that is always how we factor using difference of squares. So an example would be something like this. What if we had x squared minus 64? Well, x squared is a perfect square, 64 is a perfect square, and we are subtracting them. So this is a difference of squares problem. So it's always going to be two binomials, one addition, one is subtraction. It doesn't matter what order it comes in. But we would take the square root of x squared to get x. So the first term in each binomial would end up being x. And we take the square root of 64 to get 8, which would get us x minus 8 and x plus 8. So that is an example of using difference of squares. Another one would be something like this, 25 minus y squared. Well, 25 is a perfect square, right? The square root of 25 is 5. And y squared is a perfect square. It's literally squared, right? So the square root of y squared would just be y. We are subtracting, so once again, this is a difference of squares problem. So I take the square root of 25, which is 5. So notice that is the first term in each binomial. I would take the square root of y squared, which is y, which is the second term in each binomial. And I'm just going to have one binomial be addition and one binomial be subtraction, and it does not matter what order. Now, remember, the first step is always to check for a greatest common factor. So if there was a greatest common factor here, I would want to check for that first, okay? Then we can try to use difference of squares. It's not always going to work. It's only when we are subtracting two perfect squares. So if this was like x squared minus 30, I wouldn't be able to do anything because x squared is a perfect square, but 30 is not. So it's only if everything is a perfect square. Which leads me to a problem like this. We have 16x squared minus 49y squared. Now this one does seem a little different, but it's actually not. This is, once again, a difference of squares problem because everything in this problem is a perfect square. 16 is a perfect square, and x squared is a perfect square. So 16x squared would be a perfect square. We're subtracting, so once again, difference. 49 is a perfect square. Y squared is a perfect square, so that means 49y squared is also a perfect square. So this would once again be a difference of squares problem. And it does not matter. One of them is going to be addition, one subtraction. It doesn't matter what order. And now we would just take the square root of each term. Well, the square root of 16 is 4, and the square root of x squared is x. So the first term in each binomial would end up being a 4x. The square root of 49 is 7, and the square root of y squared is y. So the second term would be 7y, and that would be our factors, 4x plus 7y and 4x minus 7y. So that is difference of squares. That's it. So all you need to do is be able to recognize if everything is a perfect square, There needs to be subtraction. It does not work if it's x squared plus like y squared. And make sure you're able to take the square root of each term. I hope this video was helpful. If there's any questions, please feel free to let me know. And in the next couple videos, we are going to be factoring quadratic trinomials, and maybe I'll do an extra video where we just mix them all together and make sure we're able to factor everything that is thrown at us. So I look forward to seeing you guys in the next couple of videos.